Hello, everyone, and welcome to math class. Today I am replaced with, well, you don't know who. Just kidding, it's just me. We're gonna do variables and expressions today. Let's get started. Alrighty, we're gonna get started with Algebra 1 proper with variables and expressions. Variables, you know, when a letter stands for some kind of number or a symbol stands for some kind of value. Yeah, let's go. Before I get too ahead of myself with some examples, a couple of terms and definitions. First off, a variable. It's a stand-in for some representative value, right? A symbol or a number that can represent something. And it can change. It can be one number 1 second and a different value the next. But a constant is something that doesn't change, you know, like 5 or 1. Finally, an expression, a problem made up of numbers and or variables, although there are different types. For example, one is an arithmetic expression if it only has numbers, a fractional expression if it has a bunch of fractions in it, and an algebraic expression if it has a variable. Our first example is asking us to convert the words in a sentence to a sentence of an expression. So, to start us off, we need to identify what we're dealing with. First off, we have 2 more than the number of hours in a day, D. Well, 2 more, I highlighted that immediately because I noticed that it's suggesting that we're going to be adding by 2. Whatever it is that we have to add 2 to it. And the number of hours in a day, well, that's, you take the number of days that you have and you multiply it by 24. We had 1 day, for example, we'd do 1 day times 24, and then 2 more than that. Although I don't know how many days it is. It's probably more than 1. I don't know. This means that our final expression would be to multiply 24 by the number of days that we have and add 2 to it. Now, for our next example, we're being asked to write words to represent the expression. And to be fair, there are a lot of different ways we could represent this expression, going from the problem to a sentence. But I have a couple in mind that I want to emphasize. First, you could say something like twice the value of x, take away 5, which is a very straightforward way to represent the original scenario, since it does an adequate job of saying that you're doing 2 times a missing number and then subtracting 5 from it. However, you could also be clever about it. If I wanted to say that it was 5 less than the original value of 2 times x, we could say something like 5 less than twice the value of x. Finally, an example here that's 2 problems. It's asking us to simplify whether x is equal to 2 or x is equal to -3. So we will have to do this problem twice, once for the x being equal to 2, and once for the problem or x value being equal to -3. And I'll start with the 2, since it's the first one. But if we put 2 into this problem, we'll be putting it in for both x values. And it's really important that I mention here that there's no operation shown between 2 and x. However, it is most definitely multiplication. Whenever you have a number, a constant, a value in front of a variable, and they're right next to each other, that's multiplying. So we got 2 times 2 plus 5, parentheses, 4 minus 2. So where do we start? Well, we start with order of operations. I'm going to do 4 minus 2 inside of these parentheses. And then I'm going to do some, ooh, that's curious. So I'm going to do 4 minus 2 from inside the parentheses, and then I'm going to work through the rest of the problem. Now I should say this is 5 times, just like this is 2 times 2, this is 5 times 2, which means I have 4 plus 10, which is 14. So that's my first answer, where x is equal to 2, my final answer becomes 14. But since x can be different numbers, here I have to test it for if x is -3. So I have 4 take away a -3, which is going to be a value of 7. And then I can multiply 2 with -3 to make -6, and 5 times 7 to make 35. To make 35, for a final answer of 29. So because this example basically had 2 questions, one for x is equal to 2 and another for x is equal to -3, I have 2 answers, one where the result is 4 and one where the result is 29. Now that's variables in action, since one variable, x, was possibly multiple different numbers. Just a side note, you might want to watch out for some of these clue words when you're going to write expressions for different problems. Just something to keep in mind. And we're nearing the end of the video. Here on Variables and Expression, we've taken a look at what it might look like to deal with a variable in an expression. So here we have an algebraic or a variable expression. It's an expression, a problem that has a variable in it. And if you hear something like the product of 5 and x plus 3, then that's a right way to change that expression the way you hear it. It's read out that way. Or you could say something like x squared subtracted by 1. But you want to watch out and hear for things like 1 less than the square of x, since they're being clever about how they word it, but that's suggesting the same thing. Remember, when they give you a problem and a value for the problem to have, plug that in and then solve to see what you get. If they give you more than one number here, plug in each number to see what each result gives you. At any rate, I hope this video has been helpful. Take care, and I'll see you in the next one. Bye!